Hello, good morning, everyone. I hope you all can hear me. Please confirm if you can see my screen and you can hear my voice. Anyone can confirm on the chat. Can you please confirm if you can hear my voice and see my screen on the chat? Okay, fine. Thank you. So let me introduce myself first, and then we are going to start with the session. So my name is Vivek Singh, and I'll be your instructor for this particular course, a small demo course, you can say. And I delivered trainings, courses all over India and abroad on various technologies, various disciplines. One of them is structural designing, which we will be discussing today. Specifically in structural designing, we'll be discussing, uh, beam analysis and design using STAAD Pro. So the software we'll be using today is STAAD Pro. But I deliver all kinds of trainings, like there is structural designing, structural modeling, BIM, building information modeling, there is project management, there are some ISO certification trainings also that I deliver. There is quantity surveying and estimation. Okay, there is AutoCAD, all these softwares which you hear in civil engineering, all of them we deliver. So I'm associated with Skill Desire, and we are here to help you in learning new skills, which will be very much helpful for you to get a decent job and even, start your own work in any kind of field. So let's start with the session without wasting any more time. Okay, and as you know, today's session is on beam analysis and design, and the software we'll be using is STAAD Pro. So once we go through this session, I'll tell you more about the things we do and the things we have planned for the students all over India and even abroad, and how you can be part of this whole training programs that we arrange. So first of all, let's start with this session. So this today's session is based on beam analysis and design using STAAD. So the software we'll be using will be STAAD Pro, and let's try to analyze and design the beam using STAAD. But before that, I would like to know in which year, if you are in engineering, you can just type which year you are in, and if you are a pass out, engineering pass out, then you can tell me what are you doing. So you can just put on chat which year of engineering you are in, and if you're a pass out, you can just type pass out, or if you're working somewhere, you can just type working on the chat, so that I get to know what is the level of all the participants. According to that only, I'll put some questions that we will be discussing, some problems that we'll be discussing. So just put your year of engineering right now. In which year are you in? First year, second year, third year, fourth year? On the chat, you can just type. Okay. So Mohammad Abbas Khan is in third year. What about others? Third year civil engineering, I guess, right? Most of you are from civil engineering background, I guess. Okay. Aman Ahmad is also in third year. Others, quickly type in the chat. And there is Divakar, third year. Okay, most of you, I think, are in third year only. Okay. All right. So I think I get the trend. Like most of you are in third year, and yeah, third year civil engineering, most probably. So, so I'll just frame the question, frame the whole problem that we will be discussing in that manner only. So let's start with the analysis and design of a beam. So I'll just put a beam here in front of you, and we are going to see the analysis results of that beam, on STAAD. Just a moment. So let's say this is a beam. And on this beam, we have some UDL, uniformly distributed load. I'll also ask you some problems on this. Okay, let me just put this UDL in some other form, in this form. Okay. So let's say the length of this beam is, let's say the length of this beam is 10 meters. Okay. And let's say this is A, this is B, and the the UDL here is, let's say, 5 kilonewton per meter. So can you analyze this beam? Can you tell me what will be the maximum bending moment and maximum shear force on this beam? Just ignore the self weight, ignore the self weight of the beam, and tell me what is going to be the maximum shear force, maximum bending moment. Let's see who gets it right. I'm giving you some time for this. Is there any other information you want? You can also let me know. Tell me. Let's see who gets this right. Okay. So I'm getting some shear force diagram. Mohammed Abbas is saying it is 50. Okay. Others, bending moment diagram. What about the bending moment diagram? What will be the maximum bending moment? What will be the maximum bending moment of this beam? And on the basis of that, we can draw the the bending moment diagram as well. $62.5, Divakar is saying. Mahadev is saying 50 into 5. Ahmad is saying 62.5. I'm not sure. So I think I'm getting so many different values that I can't even trust which one is correct, which one is incorrect. So let me just, okay, again, Mahadev is saying 62.5, 625. So there are so many random values which we are having here. So let me just make it very simple and clear to all of you how to deal with this. You don't have to use any kind of formula. Just see what I'm doing. I'll make it easier and simpler for you, just like any other question. So what we'll do is we'll draw, one second. Yeah. So we'll draw the free body diagram of this whole beam, and it will be like this. Or let me use the black color only. Okay. And now on this we have so many answers I'm getting. I can't trust now. I'm getting 125 again, a different one. So let's see. Let me draw the free body diagram. Let's say this is the free. I'm drawing like this because that's easier to draw. Otherwise, I have to draw those arrows. So let's say this is the 5 kilonewton per meter of UDL. Now there will be supports. Oh, sorry. One thing I missed here. I'm really sorry for that. I missed the supports. That's what I was thinking. I missed something. So these supports I actually missed, but that's fine. You know, I already told you initially that it's a simply supported beam. So yeah, you would know. But no one told me that I'm missing something here. You can see a roller support and a pinned support. These two things I missed, and I'm really sorry for that. And yeah, so this is a simply supported beam, as you can see now. Okay. So for a pinned support, there will be a vertical reaction and a horizontal reaction. Since there is no horizontal force, there is no horizontal load on the beam, so that horizontal reaction will not be taken. We'll just take the vertical reaction, this one. And on the right side here, roller support only has a vertical reaction, support reaction. So that is there. Now, what will be the support reactions on both the sides? 5 into 10 is 50. And let me just put the distance here. Distance is 10 meters. So 5 into 10, 50. The total load is 5 into 10, 50 kilonewton. So that 50 kilonewton will be divided equally on both the supports. So this will be 25 kilonewton. And this will be also 25 kilonewton. So 50 kilonewton of load is divided equally on two sides, 25 and 25. Now, let me draw the shear force diagram. Let's draw the shear force diagram here. So the shear force diagram would look like this. Let's see. So left upward, the force is upward right now. See, right now I'll not be explaining you in details, in deep, why the supports are like this, because for that we need a lot of time. But yeah, I'm just telling you, I think this is something which you might be knowing. Even when you resolve the forces, you will get 25, 25 here. And as per the shear force diagram sign conventions, left upward is taken as positive. So this will go up here. And now this is 25. So this will be 25 kilonewton at this point. Now the thing is, the shear force diagram, actually, shear force diagram is equal to area of loading diagram. This is what you need to understand. Okay, and putting this in a more detailed way, I would say that at any point, if you want to find out the shear force diagram, let's say this is A, this is B, and the center point is C. So suppose at C, if you want to find out the shear force diagram at C, so what I can say is, see, this is A, this is B. So if at C you want to find out the shear force diagram, so shear force at C will be equal to shear force at A plus area of loading diagram from A to C. Now let's see how this comes out to be true. See, shear force at A is 25 because of this load, this support reaction of 25 kilonewton. So shear force at A is 25. Okay, because it is upward, so we are taking it as positive, plus area of loading diagram. What is the area of loading diagram? Can anyone tell me? See, loading is like this. From A to C, loading is like this. Like this. It's like this, right? The height of this loading is 5 kilonewton per meter. The length of this loading is 5 meter. So 5 into 5 is 25 kilonewton. So 25 kilonewton is the loading from A to C. But since the direction of the load is downward, so it is negative. And it's a cuboid, right? It's a rectangle, sorry. So that's why the area is length into breadth. So 5 into 5, 25. That's why 25. Because the length is 5 till C. From A to C, length is 5, loading is 5. So 5 into 5 is 25. But that's downward, so that's why it is negative. So negative, positive are cancelled out. You are left with 0 kilonewton. So that's the shear force at C, 0. So it is 0 only at this point. Now shear force diagram at B. Let's see what is going to be the shear force diagram at B. So let me just see this. Shear force diagram at C. Shear force diagram at B. Okay. So shear force at B will be equal to shear force at C plus area of loading from A to from C to, 1 second, from C to B. Now shear force at C is equal to 0 plus area of loading from C to B. Again, the same thing. Minus 5 is the loading because it's downward, and the length from C to B is 5 only. So minus 5 into 5 is minus 25 kilonewton. So that's why this shear force value here is minus 25 kilonewton. And you can just join this point. Yeah, from some sign conventions also you can directly get that it is minus 25. But if you do these calculations, it makes your concept clear, like why you're getting these values, that you will be very much clear about. But now, how to join these points? This is that a curve? Is that a straight line? What we need to do? See, that's a UDL here. It's a uniformly distributed load, and uniformly distributed load is like this. A straight line, uniform. That means if you look at the curve, it is a 0-degree curve. That means constant. It's constant. Now, if you are looking at the shear force diagram, it would be straight line like this, just connecting 2 points. A straight line connecting 2 points means it's 1 degree higher, 1 degree higher, which is linear. So this also I'll be explaining later on in some course why it is 0 degree, why it is 1 degree. But right now we just have to assume that it is 1 degree. See, one thing you can note is if your loading diagram is 0 degree or constant, your shear force diagram will be 1 degree because it will be 1 degree higher, and your bending moment diagram will be 1 more degree higher than the shear force diagram. That means your bending moment diagram would be like this, curved 2 degree, which is quadratic. Okay, so your loading diagram, if it is constant, that is 0 degree, your shear force diagram will be 1 degree linear, and your bending moment diagram will be 2 degree, which is quadratic, which is a curve. So since our loading diagram is constant, our shear force diagram will be linear. That means just joining these points like this. So this is positive, this is negative. So this is your shear force diagram. And this was your loading diagram on the top. So I'm just giving you an overview. I haven't even explained you in detail everything, all the concepts. But yeah, later on I'll be explaining you maybe in some other training. But yeah, this is how it is. There are lots of concepts that are involved here, which we will be discussing later on. But now let's see how we can draw the bending moment diagram. I'll just zoom out a little. Yeah. Okay. So let's see how we will be drawing the bending moment diagram. So it's the same concept we use there. Now bending moment at A, we already know A is at A we have a pin support. So at pin joint and roller joint or roller support, the bending moment is 0. It will be 0 kilonewton meter at A. Now we need to find out what will be the bending moment at C and B. So same concept will apply here. Bending moment at C will be equal to bending moment at A plus area of shear force diagram from A to C. From A to C. That's why we are taking A to C. So what is bending moment at A? It is 0. Area, what is the area of shear force diagram from A to C? It's a positive area, so everything will be positive. It's a triangle. From A to C, it's a triangle. So what's the area of triangle? Half into base. What is base? This is 5 meters. And this is also 5 meters. So base is 5 meter. Half into base, 5 meter. Base into height. Height is 25 kilonewton. 25. So it is 25 into 5, 125 divided by 2. So 2 6 12, 2 2s are 4, 2 5s are 10. 62.5 kilonewton meter. So that's your bending moment at C. So we have found the bending moment at C. So I'll just remove this. So see, I'm not using any formula. I'm just using the concept, right? And you all use the formula and you see how different results you are getting. That means you're not clear about the formula, how the formula came into existence. You're not sure about that. So maybe later on in some other trainings, I'll also show you how to derive those formulas. Then only you'll clearly remember those formulas. Because right now you're just trying to memorize the formula and then use it. That's why you're not able to actually get the whole concept. So you can see how easily I got this value, 62.5. Since I was explaining you, so it took a little while, but if you would use this quickly, you would get the answers right. And now at B, what will be the bending moment? What will be the bending moment at B? So bending moment at B will be equal to bending moment at C plus area of shear force diagram from C to B. So bending moment at C is 62.5 plus area of shear force diagram from C to B. What is the area of shear force diagram from C to B? Again, the same thing, half into base into height. Here the base is 5, height is minus 25. Half into base is 5 and minus 25. So 62.5 minus 62.5, which gets you 0 kilonewton meter. So that's the bending moment for B. At B, the bending moment is 0. That's why you get 0. And even if you don't use this formula, this whole calculation, you also know that at B the support is roller. So for roller support, the bending moment is 0. So you can see the curve of shear force diagram was linear, which is 1 degree. For bending moment diagram, it is 2 degree, which is quadratic. So I'll just draw a quadratic curve. And why I'm drawing, see why I'm drawing like this, why not like this? That is again a new, something new to discuss that I'll keep for the other course, a different training. But yeah, we will draw like this. We are drawing this kind of curve, not the other one. And there is a reason for it, which I'll explain you later on in some other course. Because this is just for 1 hour, so I'm just keeping myself. So, in a way that we can discuss everything about this. So now you can see this is your bending moment diagram. So you can see how easily I have drawn the loading diagram first, the free body diagram, the shear force diagram, and now the bending moment diagram. So this is the bending moment diagram for that beam. And if you draw the elastic curve or the deflection diagram, it would be like this. You all know that how it will deflect. It will deflect like this. Sorry. It's going to deflect like this. Now the thing is, how much is this value? Can anyone tell me the deflection value? Anyone? Deflection value? What will be the deflection at C? See, this is A, this is B, this is C. What will be the Y max, maximum deflection? I've already found B max. See, this is B bending moment max, maximum bending moment. I've also found the maximum shear force. So this is your maximum shear force. Now tell me what will be the maximum deflection. Can anyone tell me? Does anyone know what is going to be the maximum deflection? And coming on to the maximum bending moment, I think none of you got it right. Mohammad Abbas was saying shear force will be 50. No, it's 25. That's incorrect. Mahadev was also incorrect. Mohammad Abbas Khan was correct about bending moment diagram. Maximum bending moment is 62.5. So I think Mohammad Abbas Khan got it right, the bending moment. And even Divakar also got it right, 62.5. That's the maximum bending moment. But others were incorrect. What about the deflection? Can anyone tell me the deflection? Anyone? Deflection.
Yes, it is 5 by 384 WL to the power 4 by EI.
Okay. So just find out the deflection.
That is the deflection. Maximum deflection at the center.
Right. The maximum deflection will be at the center, and you're telling me the formula right now. The formula for deflection is this. Let me show you. So we can even derive this formula, but I'll just show you the formula itself. 5 by 384 WL4 upon EI. Okay, so for this we need the section property. We even need we need the section property. We need Apart from section property, we also need the material property. So let me show you how you can get it. So let's say this is the beam. Let's assume this is the section of the beam. And here we are using, let's say, M20 as grade of concrete. And the depth, the width of the beam is 300 mm. And the depth of the beam, let's say, is 500 mm. Okay. And the material is M20. So let's see how we can use this formula. So we have the section as well as the material. We can just put this into this formula. So the formula is 5 by 384 multiplied by W. What is W? W is the UDL. Okay, it is the UDL, whatever UDL we are using. So just a moment. Yeah. So it's the UDL, whatever we have on this beam, and it is equal to 5 kilonewton per meter. So I'll just put everything in in kilonewton in Newton and meter. So it is 5 kilonewton per meter. So I'll write it as 5 into 1000 because that's kilonewton. I've converted that into Newton. So now that is Newton per meter multiplied by length of the beam. Length of the beam is 10 meters, 10 to the power 4 divided by E. E for M20 will be 5000 under root FCK. FCK is 20. That's M20. And this will get in Newton per mm square. And if you want to convert that into meter, that will be multiplied by 1000 square. That is how it will be converted in Newton per meter square. Because right now it was, let me note, give you the formula of modulus of elasticity. It is 5000 under root FCK. Just note it down. It's an important formula. Okay, that's the modulus of elasticity of concrete. You can get the same formula from IS code. So if you're wondering from where I'm telling you this formula, this is from IS code, IS 456, which is for concrete. Okay, so from there you can get this formula and you can use it. And yeah, so 5000 under root FCK Newton per mm square. But you can see I'm putting everything in Newton and meter. And that's why I converted this 5 kilonewton per meter of load into 5 Newton per meter by multiplying it by 1000. But now this is 5000 under root 20. This is in Newton per mm square. So since this was mm square, I needed to convert it into meter. So I had to, multiply it by 1000 square. That's how you will convert this into Newton per meter square. And after E, we have I. I means moment of inertia. So moment of inertia of this section will be BD cube by 12. Let me write it here. I BD cube by 12. And we'll keep everything in meter. So B is 0.3, D is 0.5. So B D cube BD cube by 12. Okay, BD cube by 12. And 1 second. Yeah, BD cube by 12. And now let me calculate the final value. This is in meter already. So let me take out the calculator and find out the value. You can also tell me if you know. I will get the value in meter, of course. The value we are going to get is in meter. 5 into 5 into 1000 multiplied by 10 to the power 4 divided by 384 divided by 5000 divided by root 20 divided by 1000 square divided by 0.3 divided by 0.5 cube multiplied by 12. Okay, this is what I'm getting. 9 point. Let me know if I am incorrect. Sorry, 9.31695. Although it is 49906, but that's fine. Into 10 to the power minus 3 meter. I'm getting this. So if I convert this into millimeters, I'll get 9.31695 millimeters. So that is the answer. That's the maximum deflection we will get from this beam. But yeah, one thing what we have done is we have ignored the self-weight just for the analysis. But yeah, you can also include the self-weight. Later on, when we do more analysis questions, we will include the self-weight and we'll see how it affects the whole analysis results. So now see what are the things we have found out in this problem. First was the loading diagram, the free body diagram, then the shear force, maximum shear force 25, then the bending moment 62.5, then the maximum deflection, which is 9.31695. Let me know if I'm wrong. I think I've done it correctly and I got the right answer. If you think I've got the incorrect answer, just let me know on chat. Okay, I hope all of you are getting the same answer. Now let's do a very interesting thing. Let's verify this whole solution on STAAD. Let's see if we get the same answer on STAAD or not. Okay, so let me just switch to STAAD. I'll keep this open. A second. Let me just open STAAD. Where is it? Where is STAAD? Let me just shift it here. Okay, there it is. STAAD Pro V8i SS6. Okay. So I'm just opening STAAD and we'll do the same problem there. Okay, so I'll just click on new project. Just see the whole process in the training, which we will be arranging later on. I'll explain you everything. I will also share with you the softwares and everything. And right now I'll just show you because this whole session is for the introduction on how we can make things easier with software. You saw how lengthy it was to find out these values, although I used the most optimized method to find these values, but still it took time. It took around half an hour, but since I was explaining you, it took a little longer. But yeah, it takes time. So see how STAAD as a software can help you in that. And like that, we have many softwares, not just STAAD. STAAD is just for structural designing. There is for project management, we have Microsoft Project, we have Primavera P6 that makes things quicker for you. And that's what we need from engineers. The companies, your employer, they need this only. They need you to learn new technologies, new softwares, which will speed up the whole process of projects they are working in, and they can deliver these projects on time or even in a very short time to their clients. And that's what helps them to make profit, and that's what they want. All the employers, all the companies, they want profit. So if you as an engineer cannot provide these profit to them, then you are of no use to them. So that's why these softwares can help us, the engineers, to make things quicker. So let's click on new project. I'll just show you the whole process. I'll click on new project. I'll go to space. Let me name here, put the name beam analysis and design. Let's see if we'll do design or not, but yeah, analysis is something that we will surely be doing. Here, length units meter and force units is kilonewton. So let's click on next. Add beam. Okay, finish. So here we are. Here we are on this grid. You can either use this grid, or usually what I do is I usually ignore this grid and I directly put the values from the spreadsheet. So right now I'll not explain you how to use this software because I'm just showing you the application of software. Later on in some other course, if we arrange, we will show you the whole thing. But right now, since due to the time constraint, I'll just show you the whole process. Just look how to use this software and how easy it makes things to you. So first 0, 0, 0, then 10, 0, 0. Now we need to draw the beam, so I'll just draw the beam from here. Add beam. I can draw the beam from spreadsheet as well. I'll just write 1, 2 here. It will be drawn, but I can use this. This looks more interactive, so I'll just keep this. So beam is drawn. I have drawn the beam. The next thing is this was, and it's 10 meters. You can see the X value I've put as 10. Why 10 meters I've put? Because the length of the beam is 10 meters. So let me go back to STAAD. So this was geometry. In geometry, this was beam. Let's go to general. This is general. In general, the first thing is property. So again, I'm not explaining you everything in detail. I'm just showing you the process, how to get the result, so that you know the importance of this software. So I'll click on geometry. I'll click on, I click on general. Then I'll click on property. And we'll create a property of this beam. So what is the property of this beam? This is the property, section property. So let me click on define, and here I'll choose a property: circle, rectangle, T, trapezoidal, any property you want. I want this rectangular property for this beam. ZD and YD. YD is the depth, ZD is the width. So depth is 500 mm, width is 300 mm. So ZD is width. So width is 300 mm. That means 0.3 meters, and YD is 500 mm. That means 0.5 meters. So 0.3, 0.5. This material is concrete, as you can see here. Now click on add. The section property has been added. Now you want to assign this section property to this beam, which is here, this beam. So what you'll do is you'll select this section property here. You'll click on assign to view. Assign to view, why? Because it will be assigned everywhere in this screen. And in this screen, we just have one property, one beam, which is this. So I'll select this section property. I'll click on assign to view. I'll click on assign. It says the assignment method you have chosen is assign to view. Do you want to proceed? I'll say yes. And you can see R1 is the property which has been assigned to this beam. Why? Because why R1? Because can you see here reference REF, reference 1. R1 means reference 1. So that's the reference number of the section property. That's R1. So we have assigned the property. If you want to check the property whether it is assigned or not, you can just click on the beam. You can right click on the beam, or you can just the best way is you can just double click on the beam. Yeah, just double click on the beam and you see the geometry, you see the property, and property you can see here 500 by 300, 0.5 by 3.5. Length is also given. The material property is also given, concrete. So this makes it clear to you that you have actually assigned the properties to this beam. Okay. So next thing, let's go to support. You can see after property, the next thing is support here. Just click on support. I'll click on create. We need to create support. We need to create two supports. One is pinned and one is roller. So I'll click on create. I'll click on pinned. So I'll click on add, and the other is roller. So I'll click on create. I'll go to fixed butt. Later on, I'll explain you why we are taking this fixed butt and all. So fixed butt, and I need to release this in other directions. So usually if it's a purely roller support, I should have done like this. I would have released in all the directions except for FZ, because vertical reaction is there in a roller support. But we are going to keep we are going to release this in fy. Sorry, we'll keep this fy there, mx, or let's keep fz as as a support. Otherwise we could have kept mz, but that's fine. Fz we are keeping upward direction as a reaction. So all the directions of restraints I have released. Just Fz I'm keeping. Release means everything is fixed here. Fixed means everything is fixed. Here it says fixed but. So it says fixed but these are released. These directions are released. Just Fz is there. Just Fz reaction is there. And what do you think Z direction is? Z direction is not the vertical one. Just look at this. Just look at this direction. Fz will be Fz should be released if its vertical direction is Z. But here, if you see, the vertical direction is Y. And this is something which I realize right now, that Z direction is actually not the upward direction, it's Y direction. Just look at this here. Just look here. Actually, Y direction is the upward direction, the vertical direction. So we should not keep Fz unchecked. We should actually keep Fy unchecked like this. Okay. So Fy should be unchecked, not Fz, because Y is the vertical one. And if you remember, in a roller support, vertical direction is the only restraint, is the only support, you can say. If you are standing on a roller, let's say it's a let's say a steel ball, you are standing on a steel ball, you can move in any direction, right, on that steel ball, but you can't move up and down because that steel ball is supporting you in vertical direction. That's why Fy will not be released, all the directions will be released. So we are keeping Fy as the support for for the roller one. Otherwise, if you want, you can keep that as pinned as well. You can keep it as pinned as well. So that also we can do. If you don't want this support, if you're having any trouble with this support, just remove this. And what I'll do is I'll keep both of them as pinned. So both the supports I'll keep as pinned. So let me put both the supports as pinned. So this is pinned because it won't make any difference because all the loads are vertical. So it doesn't matter. So I'll click on use cursor to assign. I'll click on assign and I'll assign one support here and one support here. So both I'm keeping pinned just for simplicity. Okay. Later on in the training, I'll explain you the roller support as well, how to assign a roller support. There's also some changes we have to make there. But right now it's fine. We can keep this as pinned. Okay. So support is pinned on both the directions, on both the ends. And now let's go to loads and definition. Now we'll create the load. So let's click on load case details and click on add, and I'm going to create a load case. Let me say dead load, and here loading type I'll put dead, and I'll click on add. So that's a dead load I've created. I'll click on this dead load, I'll click on add again, and now I can add self-weight load, but I don't want to add self-weight load because we have ignored self-weight load in the whole beam. So what is the load for us? The loading is 5 kilonewton per meter. So 5 kilonewton per meter is the load, and it's a UDL. So let's see how we can put this. So it's a member load. Under member load, you have this uniform force. So in uniform force, we are going to put this 5. And whether this should be 5 or minus 5. If you are asking me whether it is 5 or minus 5, you need to see this direction. Just look at this direction. Direction says GY. GY means global Y direction. So where is the global Y direction? Just look at this coordinates. Global Y direction is upward, but your load will be downward. So that means it has to be negative, minus 5. So, sorry. So this has to be minus 5. Now it is asking D1, D2, and D3. See, D1 and D3 will be 0 sorry, D1 and yeah, D1 and D3 will be 0. But what about D2? D2 is the distance of this point from that point. So D1 is 0 because the load is starting from one end. You can see the load is starting from here. So D1 will be 0. There's no D3, there's no eccentricity. So D3, we don't have to put anything. D1 is 0. D2 will be the end. That means 10 meters. So I'll put this as 10. So till 10 meters, it is spread. The whole load is spread in 10 meters. Now I'll click on add, I'll click on close. Now I'll assign this load. I'll select this load, assign to view, assign. Yes, so now it has been assigned and you can see. And if you want to see the load, you can see this is load here. You can click on this. If you want to see the load value, you can click on the symbols and labels and switch on the load values. Where does it show the load value? There it is, load value. Click OK. There it is, -5 kilonewton per meter. So that is correct. And if you don't want to see the load value, just go here and uncheck it. Okay. Okay, so after loads and definitions, next thing is analyze sprint. That means we are going to analyze the beam. But before analysis, you need to go to STAAD editor. So I'll go to STAAD editor. And let's see what are the changes we have to make. So just be with me and see the whole process. You don't need to understand each and every step because I'm not explaining you each and every step right now. I'm just giving you a demo how this software works, just an introduction. Okay, so just be with me and see the whole process. You'll see the result which we are getting at. So first of all, E means modulus of elasticity. Now modulus of elasticity we had found in this analysis, and that was E, and value of E was 5000 under root FCK Newton per mm square. So let's see how much we will be getting. 5000 under root FCK, that FCK for us was 20 M20, so 22,360.68 I'm getting. That is in Newton per mm square, but here all the values are in kilonewton and meter square. So I need to divide this by 1000 and multiply it by 1000 square. Then only it will get converted into kilonewton per meter square. So it is, I'm getting 2.236 into 10 to the power 7. So that means I just need to replace this value by 2.2360679. So this is something you can also get. You just need to do the calculations. And this E plus, see this E plus 10 to E plus 007 means 10 to the power 7 only. So that's fine. So if you calculate 5000 under root FCK in kilonewton per meter square, you will get this value, 2.236067978 into 10 to the power 7. Poisson's ratio is fine. Density of concrete will keep it as 25. So let's keep this as 25. And here the strength of concrete, FCU. FCU means your FCK, your characteristic strength of concrete. So for M20, it will be 20 Newton per mm square. But here the values are in kilonewton per meter square. So I need to divide 20 by 1000. That will be kilonewton, and multiplied by 1000 square. So that's 20,000. So 20,000 kilonewton per meter square is the FCK or FCU. Now that's done. You just click on save and click on close. This is done, and your STAAD will get, updated. And if you go back here, you'll see those data only. You can see E value. This is 25 density and FCU is 20,000. So that's done. Now you just need to analyze print. So just go to analyze print. You need to, put a command on STAAD that I'm going to analyze this. So just click on analyze print. Just before analysis, we do this. So click on analyze print, no print, click on add, close. So you can see perform analysis command has been set up. Now go to analyze, run analysis, save. And you can see zero error. One warning is there because of two pin supports, but that's fine. You can go to post-processing mode, you can stay in modeling mode. So I'll stay in modeling mode. And now if I want to see the post-processing result, I can click on this post-processing. So let me show you all those diagrams. You can see the load, dead load here. Okay, let me show you all the shear force, bending moment, and everything here. But first of all, we'll look at the displacement. This is displacement. So here, this is beam displacement. So these are the displacement. Obviously, you'll not see any displacement at the ends. You can see it is zero at the ends. But yeah, at the center, you are seeing some displacement, 9.265. But that's the deflection. But I'll come to that. Here in node, you have reactions as well. So these are the reactions, if you remember. I'll just change it to front view. So 25 and 25, both are 25 kilonewton. Let's go to beam, and beam, the first thing is force. And here you can see the bending moment diagram. This is the bending moment diagram. If you want to see the shear force diagram, you can click on FY, shear. This is your shear force diagram. You can increase the scale by pressing Control and scroll up, scroll down like this. For MZ also, I can increase the scale like this. Okay. Okay. Come back. Fine. So this is the bending moment diagram and shear force diagram. If you want to see the animation, you can look at the animation of section displacement as well. Let me increase the scale first. If you want to see the deflection, this is the deflection. You can increase the scale of deflection like this. And if you want to see the animation, click on animation, section displacement. Okay. And you can see this is how your beam will be deflecting. Not exactly like this, but yeah, in slow motion, it will be like that only. I'll just change the, increase the frame rates to 50 so that it's a little slow, so that you understand how it is deflecting. So this is how your beam will be deflecting. Okay, now you will be wondering, what about the values which we had found out? Is that correct or not? So just double click on the beam and go to shear bending, and there you will see all the values. So if you go to shear bending, this is your bending moment diagram. You can see 62.5. It is showing minus because STAAD actually takes the different sign convention what we had taken, just the opposite one, but the value is 62.5. Let me show you where we got 62.5. There it is, 62.5 kilonewton meter. Here also we are getting 62.5. And why it is in kilonewton meter? Because initially only we had instructed STAAD that we are using kilonewton meter. You can also look at the units here, kilonewton meter. You can put any distance and you'll get the value of shear force and bending moment here. Suppose you want to find the bending moment at center, put the distance here as 5, and you can see the value is 62.5. Shear force is 0 at center. As you can see, at center, shear force is 0. But what about at ends? At 0 distance, shear force is 25. If you want to see shear force diagram, just change from here. Right now, it is showing you bending Z. Change it to shear Y if you want to see shear force diagram. And this is your shear force diagram. Exactly what we had here. 25 minus 25, this is 0. So that's the shear force diagram. If you want to see bending moment diagram, this is your bending moment diagram. So maximum shear force diagram is 25. Maximum bending moment diagram is 62 minus 62.5, which is exactly same as what we had found out. Maximum shear force diagram 25, maximum bending moment 62.5. And what about deflection? You might be wondering, where is the deflection now? Where are we getting this value, 9.31695? So let me show you that as well. So right now we are looking at shear bending. Just click on deflection if you want to see deflection. Click on deflection and just select whichever deflection you want to see, X, Y, or Z. So which will be the deflection, X, Y, or Z? Just look at this coordinate. Y is upward direction. So deflection will be upward or downward. So we'll check on this Y, and you can see this is our value, 9.317. You can even put the distance here as 5, and you will get this displacement value, 9.317. What we got was 9.265. 9.31695. So ours is more accurate because it is having more decimal places. 9.31695. Here it is just 9.317. So they have just rounded off. And you can see this displacement is in millimeters, 9.317. Okay. Have you all understood how we got the value? Are you all fine with it, everyone? Did you see the uh, the validation of the values? First we calculated on paper on the whiteboard, and then we checked the value here on STAAD. Is that clear to everyone? Have you understood that we got the same value what we calculated? Yes or no? How many of you got this? I'm not asking you have you understood the whole process, because I have not explained you the whole process. I've just explained you the application of STAAD. Has everyone got this? How we are getting the same value? Yes or no? Just type on chat. Just type on chat. Did you get the importance of STAAD for structural designers? Yes or no?
Yes, sir.
All of you, I want your answers on chat quickly. See, the deflection 9.31695, and here we are getting the deflection as 9.317. So I'm just showing you the application of STAAD. I'm not showing you anything. I have not explained you anything right now because I'm going very fast. But yeah, I'm trying to tell you how important STAAD can be, or any software can be. You can see this is just STAAD. I'll just close this. Apart from this, there is this software, which is AutoCAD, and people usually underestimate this software, which is AutoCAD. AutoCAD is not a very simple software. It's more complicated than you think. Okay. And there are lots of importance to this as well. There is STAAD Pro, this one. There is Microsoft Project, which is for project management. There is Primavera P6, that's also for project management. There is a STAAD Foundation, which is for foundation. There is ArchiCAD for building information modeling. There is Revit, again for building information modeling. There is SAP 2000, that is also for structural analysis and design, general structural analysis and design. ETABS is for building design, this one. QGIS is for mapping. When you get the data from total station, you can create maps using QGIS. I can show you lots of maps which I have created with students on QGIS. There is SAFE. SAFE is also for foundation design. There is Google Earth Pro, that is also used for mapping. It's actually an integration of QGIS and Google Earth Pro. Like that, there is PTV Vism as well, which is for transport planning. And there is IBM SPSS. So these are some software which I use on a daily basis, and I even teach students and employees from all over the world on these softwares. Mostly Primavera P6 is something that has a lot of requirement and for employees, but yeah, for students, all of these are really important. So for this reason only, we have come up with a few, let me just open this one and tell you the whole thing. So we have come up with two things. One is the, one second, let me just check. Yeah. So one thing that we have come up is real-time internship program. And let me just write it down here. My handwriting is really bad, so just real-time internship program. And you can get this information as well. Internship program. It will be starting from March, first week. And it will be 1 month program. And let me tell you the topics which you can opt. One is structural analysis and design using STAAD Pro. Another is design of building using ETABS. Third is Revit architecture. And fourth is QGIS, that means mapping one. These are the internship topics. And we can have more internship topics as well as per your requirement. If we get enough students, there is real-time civil industry. training as well, industrial training, or you can say job oriented training. And these trainings are for 90 days. That means 3 months. And for that, we have design of structures, structural analysis, building planning and drawing, AutoCAD, STAAD Pro, Revit, or any more softwares which you want. So lots of programs are there. You can opt for any of these. This was just for making you aware of whatever we are offering in Skill Desire. And it's now up to you whether you want to be part of this or not. You can just contact Skill Desire for any more information. And just let me know how you, what was your experience with this particular information which I gave you regarding STAAD. And I also explained you a little about beam analysis and design. You know, what's the whole process? Although the whole process is a more sophisticated one, which I will be explaining in trainings, but I have just given you an overview of both the things, how you can find out the results on paper and check that the same on STAAD, SAP, ETABS, wherever you want. Okay, so any questions you can ask me right now. I'm online right now and you can ask me. In 5 minutes, I'll be leaving and ending the session. So just let me know if you have any questions on chat. Any questions? How was today's session? Did you like the session? Was it fine? Okay, you understood the importance of STAAD. That is also good. And let me know if you have any questions regarding anything on chat. You can also unmute yourself and ask. Any doubt? No doubt? Okay. Ajay is asking, do we have to pay for the internship? Ahmad is asking, do we need all the softwares as a civil engineer? That totally, Ahmad, it totally depends on uh, which which industry you are working for in civil. Okay, if you are in some in interior designing or something related to building information modeling, in that case, for you, Revit will be more useful. If you are in designing industry, for you, STAAD, ETABS, SAP, these softwares will be useful. AutoCAD is something which will be useful everywhere. If you are somewhere related to project management, there Microsoft Project, Primavera, P6, these are the softwares which will be useful. So it totally depends on your industry, but again, you need to keep all your chances open. Okay, you don't know which industry you might be working in later on, but the more knowledge you have about these softwares, the better and easier it would be for you later on. And you can learn these softwares any way you want. You want to learn it by yourself, you can learn it by yourself. If you have any doubts regarding how to take part in these internships, you can just ask us. You can go to the website of Skill Desire. You can even contact. You might have been provided with some contact information. You can just contact Skill Desire. Ajay